Well, welcome indeed to our Theory of Practice Frequently Asked Questions tutorial. These tutorials, of course, are independent of any specific workshop that we offer. They're a means by which we hope to, in a really timely manner, address pressing questions that have come up since the last tutorial and address them irrespective of where they're coming from. Now, of course, along the way, we'll need to refer to this workshop or that workshop simply because that's where a lot of that knowledge is contained, and therefore I'll be showing notes and screen snapshots and images and procedures which come out of those other workshops. I'll show you the dot points in a second. And the questions, which I've reassembled into two categories. One is very much colour artistry, the management of colour in our digital workflows, specific to graphics monitors like our BenQs, NECPA panels, our EIZO, ColorEdge, and so forth. But also a range of follow-up questions from the last few weeks to do with more advanced ways of thinking, not just executing our post-capture processing workflows, evoking all manner of other content above and beyond what was in front of the lens, and a lot of advanced separation techniques. Now, it's interesting because I was having a wonderful time just a couple of days ago helping a dear friend prepare her upcoming exhibition files, which we will, of course, print for her as well. And that made me think it's probably worthwhile adding a few advanced channel operations into this tutorial as an extension to recent workshop-specific tutorials, 3D Look Creator, Photoshop, and so forth. So it's going to be an interesting journey, beginning with the management of colour in our digital workflows, particularly our screen-based evaluations and emulations, which will be an absolute pleasure to show you, and clarifications of those procedures that we live or die by when it comes to the calibration of our monitors for a whole range of tasks. All right, so that's the setup. Let's have a look at the topics, and I'll apply a little more insight into the reasoning behind them. So these are the questions for today, and you can see again and again screens, the difference between hardware and software, monitor calibrations, the life expectancy of EIZO screens, and how do I verify the accuracy of my graphics monitor calibration? These are really interesting questions that come up from time to time, especially ones like, I've calibrated my screen according to everything that I've learnt and the techniques and using the right software and the right instrumentation. But how do I know if I have actually achieved and can rely on, have confidence in and trust the result of those calibrations? And that goes all the way back to the very first question. And I've pre-recorded some videos to help speed up the process so we can understand the logistics, the topography of the studio, how we set up to do these things. And in order to answer any of these questions, we will have to go into some theory along the way. It's not just the act of doing it. We need to understand what we're doing. And especially when we come down to these more advanced post-production issues, questions that follow on from what we've done in recent tutorials. But the point is, we've got to have those critical intellectual distinctions, those intellectual skills in place before we start doing these things. So I'll show you how to do this. Of course, I'm not going to leave you high and dry demonstrating without helping you understand how to do this yourself, let alone the why am I doing this, the rationale for engaging with our images in such ways. But to even grasp the import, the motivation behind needing to go into these more advanced operations, we need to look at what I think the advantages are of working in such ways. So from really perfunctory considerations, what can we expect with multiple screens, multiple workstations, not just our own, but also in collaborative, collective workflows where my image has to go to someone else, a retoucher maybe, who then has to inherit it and send it to my boutique processing printing lab and so forth, where we need some sense of communality, and therefore emulation of other conditions is critical all the way through to varming the living daylights out of our images. And of course, some of these more advanced operations, they're things that we do all the time to our images. And the advantages that we see in working this way is what we're also going to talk about. We just offer these as a possibility, as something that may interest you. And that might be an intellectual interest. Wow, I've never thought about doing this or doing that, putting channels on layers and these separations. And, oh, that's a really interesting advantage. Don't know if I would ever be able to use that, but I'm going to tempt you. I'm going to show you on an image that we were working on in just the last tutorial. So there's the echo, there's the reverberation carrying through, but will we then be doing profoundly different things than we were doing in the last tutorial to the same image? So I'm going to be teasing or tempting you in a sense. But of course, this is just us offering this in the hope that for some reason, in some way, it may actually be of some help, some interest, let alone a real solution for real world problems in your own workflows. Okay, so let's start working through these questions, beginning with that first question about matching screens. In this case, explicitly, the question was about having a MacBook Pro in the studio, in the field, but then having a beautiful graphics monitor, a BenQ graphics monitor, where all the retouching and processing is done to finish off each task, each job, and been really worried about two things. One is the same image doesn't look anything like the image on these two different screens. And also, which is right? Can I trust this BenQ graphics monitor more than my MacBook Pro's XDR Retina screen? And it's a common conundrum. All right, so let's begin with that idea of matching something other than a print to our graphics monitor. Here I am in Photoshop, and this is a still frame from a video I'll play addressing that very question. Here is our EIZO ColorEdge monitor on this particular workstation. There's a MacBook Pro, and I've got our 24-step target on both screens. This is an EIZO, so we're using EIZO's Color Navigator software to adjust and calibrate that screen. This is ISO 3664 viewing conditions, down around 32 lux ambient illumination. So that's the setup, and that's what we're looking to achieve. Now, some notes from our color artistry workshop, instructions about calibrating dual screens. Noting this is an example of using a MacBook Pro. In other words, screens whose hardware is largely locked in place in the factory where they're manufactured. These are screens that the only adjustment is the brightness of the backlight. Colorimetrically, we can't adjust them. And the gamut, traditionally, of these Mac screens have been variously smaller than the gamut of our graphics monitors in the 20 years that we've had Adobe RGB color spaces in our graphics monitors. And the critical premise is that the two screens won't color match, even if they've been calibrated to the same standard, the same gamma curve, the same color temperature, and often simply because they are different screen technologies. So the question is, how do we go about doing this? So now in ColorThink, we're looking at the gamut of the M4 Max MacBook Pro I'm working on that is connected to our EIZO ColorEdge monitor. Now, on its own, we've got no idea as to what it really is. Of course, we can look at the statistics and the gamut volume and what is the white point, what is the black point, and so on. But that's quite limited in terms of understanding its relativity to other conditions. So let's turn on the display that I'm working on because the MacBook Pro's screen is closed, and there is the ColorEdge 319X gamut. The white points are calibrated the same, the black points are the same. And I've made the ColorEdge monitor black so you can easily see the differences, noting there's 5 or so % where the DCI P3 gamut of my XDR Retina display excels. Now, to put this in context, because this is remarkable, look at the gamut that I've got in a portable, lightweight MacBook Pro. To put this into context, let's turn that off and look at sRGB. And this is the gamut many of our laptops, barely in some cases, were capable of. So if our other device, a tablet or whatever the laptop is, only has a gamut as small as sRGB, then the discrepancy between what I'm likely to see on the laptop and what I'm likely to see on my graphics monitor is even more extreme. But for this discussion, I'll turn back on the MacBook Pro current XDR Retina screen. We see there's a discrepancy. So how do we go about matching these two screens? Obviously, really saturated colors at the limit of the ColorEdge monitor's gamut cannot be accurately represented on the smaller gamut of the XDR Retina screen on my MacBook Pro. It's just obvious. Look, it can't be emulated, but any colors in any images that are within both gamuts can be accurately represented, as long as they're being color managed. That is, the numbers in the file, an RGB file, for example, are being converted by the operating system's color management system into the EIZO screen or into the XDR MacBook Pro screen, and therefore the numbers are changing in order to keep the color the same. But when we need real fidelity, when we need real coherence and no surprises, then of course we use our graphics monitors to emulate something else. So often you've seen in our advanced soft proofing calibration videos that here you can't see, but under our gallery lighting up above, here we're typically holding a print made on a certain printer with a certain set of inks on a certain paper with certain software. We're trying to then make a custom calibration of the screen to emulate a print. Now here, with those gallery lighting, those print viewing lights turned off, so the only things we're adapting to more or less are our screens. Now I should point out something that has changed over time in our MacBook screens. That is, with the older models, if we tilted the screen, the gamma would change. We used to use as a desktop pattern screen snapshots like this, where the inner oval compared to the outer match perfectly. On my EIZO screen, because the base calibration is gamma 2.2, and I'll illustrate this by going to a gamma of 1.8. So now the central oval is dark, whereas the gamma of my EIZO is 2.2. And we used these screen snapshots as our laptop's desktop instead of beautiful mountains or a picture of your loved ones, because tilting the angle of the screen relative to your viewing geometry would change the gamma of the screen. We would then tilt the screen backwards and forwards, correcting the gamma. Now, with XDR screens, tilting the screen backwards and forwards, changing our viewing geometry, the gamma stays the same. How remarkable is that? So what we need to do in Color Navigator, where I've gone into the advanced functions and asked it to emulate something else. In this case, I've selected the color LCD profile of my MacBook Pro XDR screen, and I'm now asking Color Navigator to create a custom calibration that emulates this screen. Now, unfortunately, even though it will use the colorimetry of this MacBook Pro profile, you still won't necessarily get a really close match between the two for a whole series of physical, psychophysical, environmental, and other issues, as we've gone over in recent times. But it's a good place to start. And you can also ask it to try and emulate one of your printer profiles. Again, you won't get that perfect match, but it will be a much closer starting point for a custom calibration. So here in Color Navigator 7 for my ColorEdge 319X monitor that we're working on, under this particular mode, I have that emulation. I just went down into the advanced functions and then asked it, not validation, we're coming to that, not the custom manual adjustment, but what is it that I'm trying to emulate? It's an ICC profile. So that's a place to start. The problem is, it still won't necessarily be spot on. So we still need to manually adjust the result. Now let's look at this procedure. And this is a video that I made just to save time. And I'm in the advanced manual controls, where I'm trying to adjust the red, the greens, and the blues to better emulate what we see on the MacBook Pro screen, making these adjustments, the red, the green, the blue, the yellow, magenta, and the cyan. I'm iterating these adjustments just as I would for a print. Notice my viewing geometry. The camera I've positioned right behind me, just as I would hold a print. Now, having done that, I then run that calibration and save it. And I've just sped this up enormously, as you can see, where it's measuring the color palettes, all other colors, and then I'm naming what I've done, an emulation, which is a custom calibration above and on top of what I already achieved, emulating the default system profile that's registered in the Mac OS for my MacBook Pro. So what I need to do now, hopefully having gone through the procedure we follow, noting that the monitor with the largest gamut we use to emulate the monitor with the smaller gamut, because we can't do the opposite. The second point is when we're creating these custom profiles, how we organize them in our Color Navigator software, or whatever the software is that we're using to do custom calibrations of our graphics monitors. How we organize these things is also of critical importance and will depend on your workflow. For example, while I'm editing on my full gamut EIZO ColorEdge screen, do I need to be able to just hit a button and immediately jump to the Color LCD custom emulation to check how it's going to look if someone then views it on their iMac or their MacBook Pro? And with the current Mac OS system settings, our displays, and there's the color profile for the connected monitor. Now, the problem is when I turn off the EIZO and open the MacBook, I'm using the inbuilt XDR Retina display and a different system that uses reference presets, which brings me to this question about custom calibrating an M-series MacBook Pro screen. And this also is leading us to the difference between software and hardware calibration. These XDR screens need controls above and beyond simple ICC profiles. So we have these reference presets for the MacBook Pro screen, and I can make a custom reference preset where I can measure my screen and tweak the default settings for that particular preset, maybe the photography D65 preset, 100 candelas per meter squared brightness and so on, and then make a custom profile and register it on top of that custom preset. I'd suggest this is more complicated than it's ever been. Not for my EIZO as an external monitor, but for the MacBook Pro screen. So now I've opened the Mac OS Color Sync utility, and in my devices, the only display that is currently in operation is my ColorEdge. And the factory profile is registered, and the current profile is where I can change it from the factory default to my custom calibration, in this case when I'm broadcasting over Zoom. That's why I've got Zoom on the end of that profile name. So this is where we can both check what is registered, what is currently being used system-wide, and therefore what other applications, as long as we haven't turned color management off in an application like Photoshop, where other applications use that emulation, that calibration, be it a reference preset for my MacBook Pro XDR Retina screen, or whether it's a custom calibration that's currently in use, which is what I'm recording on my ColorEdge screen. And in Photoshop, when I say making sure color management is turned on, means we haven't by accident got monitor RGB selected, because that turns off the color managed path. So the RGB triplets, the red, the green, and the blue brightnesses, are then being sent through the Mac OS Color Sync color module and converted into the current profile for that monitor. Not the factory, but my custom profile. But if I turn on monitor RGB, the numbers are sent directly to the screen. It's assigning my images, RGB triplets, into the gamut of the screen, so it is completely non-color managed. You can't do this in Lightroom and Capture One, but in Photoshop you can triple check that is as it needs to be. So there's a few observations answering those questions about emulating screens rather than prints. We're using our beautiful graphics monitors to do this irrespective of what it is we're emulating. But if you've got that device profile, this can even be a printed profile from the lab that's making your large exhibition prints. And at the very least, just create that emulation on her monitor, in her working viewing environment, how those images are going to transpire through a hardware calibration. So this brings us to that distinction. Again, we're still talking about monitors, that distinction between software and hardware calibration. Now, with our beautiful graphics monitors, assuming we're using the software that the manufacturers of those graphic monitors supply, Color Navigator for our EIZO screens, Palette Master Ultimate for our beautiful BenQ graphics monitors, and so on. assuming we're using the right software that can talk to the hardware, because with graphics monitors, the calibration sits in lookup tables in the monitor itself. Not so with my XDR Retina screen on my MacBook Pro. As I said before, apart from the backlight, this hardware is locked. Not so in my Cintiq using an NEC PA panel or my EIZO ColorEdge over here. Now, the problem with the MacBook Pro screen is I've only got control over the brightness of the backlight. How then do we change the characteristics of that hardware locked, not hardware calibratable screen? Of course, the only way you can do that is change the video signal, the signal being sent from the video card inside my MacBook Pro to my Retina display. It's the only way you can do it. There's no other way. And I'll use a Photoshop curve to illustrate this. For example, at the moment, I'm sending 100% red, 100% green, 100% blue. There's my lookup table output curve. But let's say the default color temperature of this MacBook Pro is 6500 degrees Kelvin. And remember, I can call up a reference preset and then put a custom calibration on top of it if I'm so inclined, if I need that level of perfection. But hang on, what is the reference preset in my system settings doing when I select, let's say, a D50 emulation rather than the default photography D65? Of course, it's got to warm up my screen to get it closer to a correlated color temperature of around 5000 degrees Kelvin. So it's got to reduce the output of my blue channel and tweak the other channels, keeping one at 100%, to have the screen emulate something closer to 5000. I'm overdoing it, obviously, to make a point. That's software calibration, where that reference preset, with or without a custom profile, is changing the output of our video card. Now, in one sense, there's nothing the matter with that because it works. The problem, at times we can end up with posterization. Now, maximum blue is less than 100%. It's 90, 80, 70%. So I've got only 70% of the bit depth in the blue channel. So the threat is posterization can become visible. I have been able to force visible posterization in blue skies that is not in the file because of what we've done to the output of the video card. And in mission critical circumstances, we end up with visible posterization because we just don't have enough steps in an 8-bit video card output, not magnificent 16 bits on an EIZO. If we've only got 256 levels in our red, green and blue channels, for example, we don't have a higher bit depth video card. If that is the case, then we're potentially starting to get into trouble, and that's software calibration. Now, as I said, there's nothing the matter with software calibration. The mistake that we see happening all too often is someone with a BenQ graphics monitor or EIZO CS or a CX ColorEdge model that doesn't have a built-in colorimeter. They buy a Spider, they buy an i1 Display Pro from X-Rite, but instead of using it as an external device selected in the Color Navigator software, they use the software that came with the colorimeter rather than Color Navigator. So when I click my recalibration target, here I've got that built-in sensor, but if I'm using a Spider from Datacolor, then that will appear in that menu. But I'm doing that through Color Navigator, which, unlike using the non-EIZO Color Navigator software, and therefore executing on the video card in my workstation, a software calibration. I'm just cheating myself because the whole reason for working with an EIZO screen is to be able to hardware calibrate it. Some other interesting questions that follow on from that. I mentioned them earlier on. There's what is the life expectancy of these graphics monitors. We invest a lot of money and time earning that money into the purchase of these graphics monitors. Now, I don't have any data spread over large sample sizes of the longevity of these monitors. We have more anecdotal information on EIZO screens because they're so ubiquitous. We do have access to EIZO Australia and their repair facility here in Australia. And over 20 years now, I can only remember, and this is running dozens and dozens of ColorEdge monitors at university in all of our studios and computer labs and so forth. I remember only one that was faulty, and it was replaced in less than 24 hours. I remember talking to my friends at EIZO in Sydney, their repair technicians, and they say as rare as hen's teeth. Colorimeters that drop down, sometimes they get stuck and what have you, but really it's not that much of a problem. It's when people drop them or other things happen that we then have to replace bits to get them back up to a new status. And that really blew me away. But now, again, that's anecdotal. But we have in operation still a CG220, the very first almost Adobe Gamut monitor to come off the production line in Kanazawa in Japan. I've been there. I've seen all the data of the testing of that very first monitor of ours. That monitor is still, today, is still well within spec. And the CG221, which came out shortly after it, was the first to have the dewy, the uniformity and color and brightness all over the screen, way before mini LEDs and so forth. That is in the back of our studio. That is the monitor I still trust above and beyond any others that I make your custom bespoke printer profiles on, where I'm doing all sorts of visualizations, not just by the numbers, but according to my aesthetic judgments as to how that particular paper, etc., should look. At least that's what I'm offering. That monitor is still there all those years later. Now, we don't run these all day and all night. Maybe only 50% of the time, those monitors during our working week from 10 a.m. to 10 p.m., 7 days a week, maybe only 50% of the time those monitors are running, but they are still as good as new. So anecdotally, we don't hesitate, though it might take a while to save up and purchase that screen. For us, these are really long-term purchases, like our lenses, even though we might upgrade those camera bodies or digital backs over time. Now, verifying the calibrations we've done. How do we go about doing this? Let's go through a series of examples. And by that I mean, let's look at how the built-in validation process operates. And I'll show you a couple of variations on the theme, plus some results, and we'll interpret those results. We'll look at the numerical reporting, because that's what a validation is. It's a measurement of the screen's behavior according to a set of known conditions. This color patch, how accurately, according to Euclidean delta E metrics, how close are we, and what are the errors or differences, and therefore by what degree of confidence can we have in the accuracy of that calibration, be it for emulation or just working on a magnificent wide gamut, state-of-the-art graphics monitor. And as I was showing you before, when we choose the sensor, when we're doing a validation, it doesn't make sense to use a different sensor than the one that we use to calibrate the monitor, because then you're inducing other errors. So we're going to be using the same sensor. Under our advanced functions, that's where we get our validation targets, at least in our Color Navigator software. And we notice RGB, CMYK, there's a whole range of registered data sets, and the basic RGB is just like a 24-step color checker, fast and furious. But look at what I've also loaded. The ISO 12646 displays for proofing ISO standard. That default calibration in our advanced soft proofing calibration videos and notes and so forth. But what have I also added? One of our bespoke printer profiling test charts, 1,748 patches and even sampling across the entire gamut. Now, of course, 1,748 patches takes a little longer to display and measure and report than basic RGB 24 patches, but they're targets that I've loaded that enable me to investigate different monitor emulations. For example, a dear friend of ours with his beautiful BenQ SW 27-inch screen, using the i1 Display Pro colorimetric device, doing a basic verification. Basic verification. Look at all the gray patches. And these are the results. That is what the patch was, pure white. These are the target numbers, 100% lightness, no A, no B, no color, and this is the result. And then the delta E 2000, which is a metric closely correlated with the human visual system. It's not perfect, but it's one of the best for the sort of validations we're doing. And then we go through each of these patches and these delta E's. Now, remembering a delta E of 1.0 is theoretically meant to be that point where you think, I can see a difference. Is there a difference? I think I can see a difference right on that threshold. Now, this is not even all throughout the gamut of the human visual system, but it's a good attempt. And you can see some patches like 40 RGB levels. That's the lab numbers target, and that's the lab numbers out. And the difference, the Euclidean straight line delta E2000 difference in that case is 2.41, which implies I should be able to see a difference. Now, with this particular BenQ Palette Master Ultimate software, driving our BenQ hardware, it's not giving us visual before and afters as some of our other validation applications can. It's just giving us delta E's. But isn't it lovely that it summarizes this for us? If all we're needing is to make sure there's nothing untoward before I launch into exhibition printing or whatever job it is that I'm doing for myself or my friends. And look at this. Sometimes we get a green tick, as I've shown you in other tutorials. You pass their standard, what they feel is a pass or a fail. The average of all of these readings needs to be less than that threshold of 2.0, delta E2000 2.0. And look at this beautiful BenQ. Oh, it's romped it in. Absolute accuracy. And the maximum error on one of these patches. Now, there's only 24 patches. It's not thousands of patches. Oh, 3.1. So what's 3.10? Here it is. It's a really dark red. 64 levels of red, no levels of green, no levels of blue. It's really dark. You're going to be struggling to see whatever that error actually means. So we also need to interpret these maximum errors along the way. So there's just a few observations, a few little hints and clues to do with the validation that's built in to so much of the software that we use to hardware calibrate our beautiful graphics monitors. And also what we do from time to time, which is extensive validations when trying to emulate a particular printer profile, where I'm using the 1748 or the 5204 or whatever the number of patches that I used to create the bespoke profile of that paper ink printer software combination. I then run that through. Yes, you go and have dinner while it's doing this, of course, because it's a lot of measurements over a lot of time. But I just want to make sure and see, and oh, wow, in these violet purples, gee, I've got a delta of 4s. Let's have a look. Yeah, I can see a difference in my friend's work. There's a lot of those beautiful bluish violets. I'm going to do a tweak on my custom calibration where I've got one of her images on the screen next to the color checker as I'm adjusting my advanced manual adjustments, and I'm going to save that as a custom printer profile for my dear friend so that when I'm doing the final tweaking, as we will do at the end of this tutorial, of my file to make them absolutely as good as I can make them print ready for exhibition printing, then of course I'm going to be viewing those images, soft proofing those images in the hardware custom calibration, including the tweaks based on what I discovered using the target 1748 samples, patches that I used to make the bespoke profile in the first place. So that's extreme, of course, but it's what we get up to here from time to time because we can, but also because it polishes everything else that we're doing. And you don't have to do this every day of the week. Now, something else that has been bothering me as I've been going through some of these situations, and that gets to this other question about what device do I use to calibrate my screen if I do not have a colorimeter built into my screen? This is implied in some of the dot points listed in our topics for today. And for example, our friend has a whole series of colorimeters from Calibrate and Data Color and so forth. And is one better than another? And he even has an EIZO branded colorimeter. Is it the same Spider I could buy from Data Color or something else? Now I've got a Spider 3, Spider 4, and these are old devices. And apart from the different color, they look more or less the same. And they're Data Color Spiders. But this is the one from EIZO. Now, way back then, I wondered, is there an advantage to using this? Or is it just the convenience of EIZO supplying a colorimeter that they know their screens and Color Navigator work with? But if I've already got a data color spider, why couldn't I just use that? We pulled these devices apart. These are colorimeters, not spectrophotometers. And we looked at the sensors, which have color filters over them, sharp cutting color filters. And I removed the color filters and I measured them with a spectrophotometer. And lo and behold, the EIZO had slightly different spectral distribution in their color filters that are tuned more specifically to the colorimetry of the EIZO monitor. Now, as we have moved forward with newer and newer devices, in this case, spiders from data color, the accuracy that we obtain with external devices don't seem to be significantly different. But if you do have a colorimeter from EIZO, even though we haven't measured those filters, I would imagine there's a good chance that's EIZO branded because the colorimetry is tweaked to be closer to the spectral distribution of the monitor. For example, in Robin Meyer's magnificent Spectra shop, with a beautiful high-end spectrophotometer. And I've displayed on my iPad Pro a grayscale and pure red, green, blue, cyan, magenta, and yellow, and I've measured those values. And here is the measurement of 100% brightness on that screen. This graph is what I'm really interested in. And you can see how the filters that are in the LCD screen, the pixels, and the red filter, the green filter, and the blue filter, and the amplitude of brightness coming through those microscopic filters and colors that are between indigo, blue, and green are then interpolated. So it's not a continuous spectrum as daylight is. Now, if you're trying to measure the colorimetry of this screen, and if, let's say, we've got 3 sensors, photodiodes, in the colorimeter, it would make sense to have a sharp cutting filter over one photodiode that pretty much mimics the range of wavelengths and frequencies in the blue region close to the colorimetry of the screen. And the same with a green filter and the same with a red filter. But this also begs another question. And let's look at that spectrum. And if I'm using a spectrophotometer, not a colorimeter, to do these measurements, and there are various ways of doing this, with prisms or with a diffraction grating. Remember, 1666, Newton held that right-angle prism up to the light coming through a hole in the shutters of a darkened room and separated white light into the rainbow, the spectrum. And the genius of the man was to use another prism in front of the first prism to condense the rainbow back into white light. And since that time, diffraction gratings, when light passes by an edge, it's diffracted, and different wavelengths are diffracted to different extents. And with a spectrophotometer at certain intervals, 5 nanometer, 10 nanometer, 1 nanometer intervals, we measure the relative amplitudes of those frequencies and wavelengths of light. But a colorimeter is not a spectrophotometer, which is why we are typically only using 3 photodiodes with filters in front of them to capture the red, green, and blue light, just like color film, and with mathematics turn it into meaningful numbers that we can visualize. So there's a basic explanation of spectrophotometers, diffraction gratings, and the sampling intervals compared to colorimeters, which are a fixed device, not sampling spectral data. They're measuring the green, the blue, or other intermediate amplitudes depending how many sensors and how many filters divide the spectrum up into 3, 4, 5 diodes, but not hundreds of samples from near ultraviolet to near infrared at the level the spectrophotometer is able to distinguish at 1 nanometer intervals, 5 nanometer intervals, 10 nanometer intervals, and so on. That is why, with our ColorEdge screens, with built-in colorimeters, you know that the filter set is tuned to perfection for the colorimetry of the screen, the filters used to create the red, green, blue light we mix together to actually see what we see on our screen. I thought I'd be remiss if I didn't extend our discussion, having gone through emulation validation, to acknowledge those differences. And if we go to EIZO's website and look up a particular monitor, in this case, not a CG with a built-in colorimeter, but a beautiful CS monitor where we need the external device, and look at accessories, color matching tool, EX5, EX4, EX3 from Spider. These are tools that EIZO are saying work with this model. So it's simple, isn't it? If you need an external device, you ask the manufacturer what their recommendation is. Updated 19th of June this year. There's the EX5 compatibility update. It works with the latest OS and Color Navigator software. Now, the other questions that came in had to do with quite advanced stages of our post-processing workflows. For example, following on from what turned into an ongoing discussion about using degrade functions, not color grading our images, but ungrading them, degrading them, because we want to grade them differently or we want to use those effects on another image. And this obviously stirred up some interest in degrading, which is a huge part of image signal processing if you think about it. And are there yet more ways than what you've shown us? And other discussions we've had recently, channel operations, for example, Adobe Photoshop Masterclass workshop. Can you give us some more examples of channel operations? That obviously stirred up a lot of interest, intellectual, procedural, creative, and otherwise. So let's spend a little bit of time finishing off looking at these considerations. In Photoshop, I recognize this image from the last tutorial. My dear friend Polly Papapetru's The Wind Watcher from the Dream Keepers exhibition all those years ago. And what have I got as layers? I've gone into 3D Look Creator, loaded that image. I've got 3D Look Creator sitting on top of Photoshop so we can still see our layers. I'm in the curve function, and on a min, max, mid method, I'm going to degrade and remove the color editing that I applied to Polly's image. And I can extract the master curve, the luminance curve. So I've separated the tonal composition, and there are the color adjustments. You can see the red, green, blue curves. Now, the master curve is active and the red, green, and blue curves are active. If I turn off, for example, the master curve and export that LUT, I'm exporting the color, the red, green, and blue curves as a LUT. And if I do the opposite and turn off the red, green, blue curves, then I'm exporting the tonal composition in that LUT. And I can assemble them. For example, there's the tone on and off. There is the tone inverted. And here is my color extraction. And there's my, using a different degrading function, my min-max color extraction in order more intense. So the idea that I can take an image, degrade it, evoke all manner of effects. Gee, the tonal composition I really like, but I like it without affecting color, just to be a little more intense, 29% more intense. There I am, before and after. So I can make subtle, fast, furious edits without having to renegotiate, in some cases, a very large layer stack with different corrections and adjustments that were originally needed to do what I did to this image, to make it print ready, exhibition ready. I can do that, but I can also use these LUTs to take the mood, the color composition, or the drama, the tonal composition, and apply that to another image that I need in a sequence of images, pages or prints organized on a wall of a gallery. I can take the tonal composition of this image and immediately, as I've just done, apply it to the next image and the next image and adjust it as needed to quickly make the tonal compositions, the drama in those images, come into cahoots with one another. But to move into the next question, channel operations. This is like channel operations, isn't it? We're not going into channels, not at all. What we're doing, though, is extracting, separating out key components of our image based on certain criteria, degrading on average, degrading on min, max, mid, and so on, just the green channel or just the red channel, and then applying that back into this image when I want more or less, but also to other images in sequencing, in the narrativizing of our images into something above and beyond just a single statement. So this begs the question. I've separated the tonal composition from the color composition, and I can dodge and burn. I can change layer strength, opacity. I can then mix and match the image back into itself, a remix. But Les, can you give us even more examples? All right, that's the 3D Look Creator. That's the Degrade function example, where I'm using it to degrade into the tonal composition and the color composition to apply to the image where I want more or less of what I've already got without having to change everything else in my layer stack. But also I can then apply to other images for their narrativization, their sequencing, their storytelling, their collaboration and cooperation. But Les, can you tell me even more? All right. So let's roll up our sleeves and dive deep into channel operations, and in particular, separating our image in quite profound ways, which will give me a chance to really demonstrate and talk about the advantages of doing this, which is just the rationale of why we bothered to do this. I've just got the background image now, and I've got an action here, a whole series of steps that I'm going to play to save time. Then I'll break it down and explain how you can do this yourself. Let's play that action. And I've put a stop in that action. Les, you've separated the luminosity, the tonal composition, from the color composition, and it equals the original image. What? So I've stopped this action at this point to demonstrate what I've done, and then I'm going to continue and push this an order of magnitude beyond what we've already got. Now there's the image. I've renamed it original so that it's unlocked and I can move it around as well. And I've separated it into the tonal and color compositions. I'll show you how to do this in a second. So if I go up here, oh, that's blended on luminosity. If I blend on normal, there is the perceived brightnesses, according to us, our human visual system, of the colors. That's what luminosity is. And extracting the luminosity and blending on luminosity, I turn that off and now have the opposite. Here is the image minus the tonal composition, which means I've got the hue and the saturation. And I'm using a very colorful image, so that the differences are quite dramatic. And look at all the yellow amongst the greens and so forth. And if I turn that off, there's the original image. But have I really separated Polly's, the Wind Watcher, into its tonal and color compositions on separate layers? The easy way of proving that is to move the original above the tonal and color compositions and turn the original off and on. I cannot see any difference. I go to my difference blending mode and my info palette, it doesn't matter what metric we're reporting, 0, 0, 0, 0, 0, 0, 0. Okay, so I have separated out my tonal and color compositions. Let's pop that back to where it was. I'll reset my workspace and go back into my actions, which are currently stopped at that point. Now, let's go all the way back and reload that original image and turn off that stop and play the whole action. I've still got my luma and it's still blended on luminosity, but chroma, the hue and saturation, what have I done? I've duplicated it 1, 2, and 3 times. And as you can see from the thumbnails, I've flattened the green curve and flattened the blue curve and thereby extracted the red. And I've zeroed out the red and the blue channels to only have the green, and I've done the same here with the blue channel. So I've taken my red, my green, and my blue channels and put them onto separate layers. Yes, channel operations on layers. This is way beyond colorizing, where I add an empty layer and with my eyedropper select a color and fill it with that color and blend on color, and then maybe put a red channel mask or some other mask or just a hand-drawn mask on top of it. No, it's proportional colorizing. Okay, I need to demonstrate what I mean by this for it to make sense. And a simple example is if I invert the red channel layer mask, turn it black, and I turn it on and off. Now, what I'm looking for in the image, by reducing that red channel, am I seeing any areas in the image where I'm getting improvements? Just have a look at the dress. Let's turn that back on. and I'm looking at the detail that's missing in this out of gamut red dress. We demonstrated this in last week's tutorial, and I invert it. Oh my goodness, look at all the density and detail that is back in this dress. So, for example, I might, painting with black with a nice soft brush tool, maybe 30% opacity. Let's paint on that layer mask 30% black, just like that. So I'm removing some of the red channel locally. I turn that off and I turn that on. Now let's go to the mask on the green channel. Let's invert that. You know what I'm seeing. What's happening when I'm removing green from the sleeves, from the trim on the dress. Maybe a smaller brush, for example. Painting with black. This time, I'm going to paint with 100% strength. I can always attenuate it. And this is subtractive. I'm removing that green channel from these areas of the dress. Smaller brush to outline the necklace. Are you serious? Let's turn that mask off before and after. Look at what is happening as I'm removing green from those blues and reds. Now, of course, this is at full strength, but if I go into my properties with the mask selected, I can use my density slider to take the effect completely off and to add whatever degree. If I've got the drawing in the mask more or less right, I can then dial in to whatever extent I want those adjustments. But just have a look at what happens to the figure, even zoomed out like this. If I turn that off and I turn that on, just look at how not the face, not the look, not the hands, not the feet, but everything else is rushing towards me. And the wind is now taking those balloons well and truly somewhere else. Wow. Now, what about the blue channel? Let's invert that mask. Oh, yes. Look at the gold that is now erupting into all of my foliage. But I'm not going to apply it all over the grass. I want to increase the dimensionality, the presence, the fecundity of the environment that the wind watcher is in, is measuring the wind, reporting on what's going on. So again, I'm going to use my brush tool, maybe slightly bigger, very soft, of course, and a 50% opacity, painting with black, and then run across some of these areas like so, where the gold already exists. I'll do this quickly with a mouse. There you go. Let's Alt-click. But what am I doing? Removing the blue channel from these areas, allowing its opposite, the golds, to erupt. Okay. I turn it off and I turn it on. Now, at 50%, it's quite subtle. Let's pull back just a touch so we've got a grey surround all the way around. And let's turn that mask off and on. I wonder if you can see over the video, off and on, just how much more three-dimensional. Because as I'm attenuating some of these values, the golds, not the greens, turn that off and on. Oh my goodness, look at it, three-dimensional it's become. Because the warmer tones are now even warmer and the greens therefore appear cooler, though they aren't because I haven't touched the greens. Off and on. And in a massive 50-inch by 50-inch exhibition print, that starts to dance. I just need to even some of that up. And the whole image then, off and on. And I haven't even begun working on the drama in the image. I'm just showing you some simple advantages of why we work in such a way with proportional colorizing. It's painting with color as much as painting with light. But by having separated the color composition, the three channels, hue and saturation to separate layers, noting that these are all blended on lighten, and the luminosity extracted, blended on luminosity. If I now, for example, add a curve to my layer stack and clip that to the luminosity layer, and let's put a node on my combined RGB curve for the red luminosity. And let's put a node up here representing the ocean. And where are the grains? Maybe something about there. So there are the dark grains. Now, even though textbooks and web pages and Adobe's own help says points on a curve remain locked down so you can adjust other points with impunity. Now, we know it doesn't work like that, but Once I've extracted the luminosity, the black and white tonality in the image, and attached an RGB curve to that, now when I start moving one node relative to another, look at the reds, look at the reds, look at the reds. They're not moving. You have got to be kidding me. This is how we actually make curves work. So as we calm down our separations into our color compositions, if I, for example, attach a curve or any other tool there, it's affecting my entire color composition. Clipping it to the red channel only affects the contrast in that red channel. Unbelievable. Off and on. Just look at what I'm doing to these reds. Off and on. Look at what I'm doing to these greens. Off and on. And remember, this is really the only place in Photoshop we have multiple nodes to edit with. I know there's only 16, not thousands, as in 3D Look Creator, DaVinci Resolves. We don't have grids. We've only got splines. We've only got curves. But it's better than nothing. At least we've got this in Photoshop. And suddenly, look at what I'm doing just with nodes on curves by having divided and conquered, as we used to call it. Now, there's an addendum that I should point out. You saw me when I put the original above our separations, not with these adjustments, of course, and blended on difference. And I looked at my info palette and 0, 0, 0 for every pixel. There was no difference. But as we've shown you in other tutorials, certainly in other workshops, this is not always the case. Now, I note that Polly's image is in DCAM4 Joseph Holmes, which is really close to ProPhoto RGB, but with a Joseph Holmes magnificent, handcrafted 1024 point 10-bit tonal curve, the most perceptually uniform tonal transitions I've ever come across. And that's purely an aesthetic judgment, nothing more. That really matters for someone like Andre and I. But what if when I put my original above, having separated everything, and turn it on and off, and some of the most saturated colors are changing? I blend on difference, and there are numerical differences. When we're in a gamma encoded working space, remember I've shown you this, even color mixing in our Photoshop color settings, we can't mix colors correctly if we're using a gamma encoded profile, Adobe RGB, gamma 2.2, ProPhoto RGB, gamma 1.8. No, we need a gamma 1. We turn that on in our settings, save them as custom settings. So when I'm mixing paint over here, red plus green equals yellow, not brown gunk. I showed you this in other tutorials and certainly in the workshops. So not working in a gamma encoded space, but a linear version of those gamuts, that works. But I've gone over some of the compromises of doing that, especially if you're not working with 16-bit depth files. So what's the solution? Well, the solution's quite simple. For example, there's sRGB, and let's say the working space that my image is in, not DCAM4, sRGB. And let's say out here in the most saturated areas, I've got meaningful colors, and I do those separations, my tonal composition separated from my red, green, blue channels, the hue, saturation, color composition. I'm ready to start advanced aesthetic, painterly, proportional colorizing and so forth, but it's not a clean separation. These colors in the most saturated 20% of sRGB, they're not separating, but they're mission critical colors. Yes, you could then use a linear gamma 1 sRGB gamut and work in that, and then they'll separate perfectly. But the simple solution, we just need a color space larger than my working space by about 20% in the areas where I'm getting these errors. You might go to ProPhoto RGB, where you're guaranteed, even if you're already working in Adobe RGB, that you have that headroom. Because even though your colors are still the same, in this case sRGB colors, they're a different set of numbers in the ProPhoto space. Instead of being 90% red in sRGB, they're now 90, 80, 70, 60, 62 or 3% red in the ProPhoto RGB space. The color's the same. It's still being converted to my monitor profile correctly. I'm still seeing correct color. Except now, when I do the separation, in this gamma encoded space, which creates errors out here towards the gamut boundary, none of my colors are anywhere near the gamut boundary, so they separate perfectly. And what did I show you? This image is in DCAM4. Now, If we look at Joseph Holmes' magnificent working space profiles, there's Chrome 100 for our scanned film. Down here, DCAM 2s, DCAM 3s. Let's say I'm working in DCAM 3 and look at these profile variants. So what we'll do, if we find working in the smallest color space to contain all of the colors in our image, so we've got maximum bit depth assigned to gradations, skin tones, beautiful smooth skies and so forth, maximizing the quality via maximizing the bit depth attributed, especially in 8-bit files. You can see these differences if you care. We will then convert our image from DCAM 3 into DCAM 3 plus 20 and run the action and do that separation. Yep, everything's separated. So I'm still working in the smallest possible gamut where all of those colors can be separated, as I'm showing you on the right, in the layer stack without compromise. But because these are LUT-based profiles, changing saturation without overly affecting hue or tones, which is the purpose initially of these variants that the great Joseph Holmes created and that we still use prodigiously to this day, we're still working in the smallest gamut that can encompass everything we need to do without having to leave our gamma-encoded spaces. So I just point out how we go about using profiles to do these separations to result in what it is we're wanting to do. But I'd be remiss if I didn't finish off backtracking because a lot of you won't have this action. We call it Lobster because my dear colleague that I had the privilege of spending nearly a quarter of a century teaching with in RMIT University, when he retired, we worked this out in the mid-1990s to fix broken bits in Photoshop. When Ian retired, we took a lot of the stuff that I'd worked out back then and he turned it into a plugin for Photoshop to enable us to do these separations, to be able to edit at a level of fidelity. But Ian's passed away and Lobster is no longer a product. So let me quickly show you how this works. And I'll go back to our original. I've duplicated 2 versions. Now, there's a myriad of ways you can do this. And for some of you in the Adobe Photoshop Masterclass and Color Artistry Workshop, I will have shown you this already. Here, I'm going to the Fill command to choose a neutral color, say 50% gray. If I blend that on color, what do you think's going to fall out the other end? Of course, it makes no sense, does it? 50% gray, there is no hue, there is no saturation. That's why it's neutral gray. So rather than panicking, Photoshop separates out the luminosity, the relative perceived brightness of colors. Now, in the black and white digital image workshop, all of those ways of converting RGB data into grayscale data, into various beautiful, not just historical emulations of black and white film, print paper combinations, but also the luminosity extraction that our medical and scientific friends love so much because these tones, relatively speaking, based on our best research of how the human visual system see these things, and anyone who's ever exposed panchromatic black and white film photographing a beautiful red rose against green leaves. The color difference is massive, but the tonal difference is identical. That's why I'm also using Poly's image. I then blend on luminosity. Now, I can change that, I can dodge and burn that, and I can add curves, as I've shown you, and thereby radically alter the luminosity with minimum effect on the color composition. I'll turn the luminosity off, do an edit fill, but now I'm going to blend on luminosity. And what do you think falls out the other end? There's our color composition, our hue and saturation. And luminosity, I can just blend a color on normal, then move the original image to the top, and I turn it off and I turn it on. I then duplicate color 3 times and flatten the green and the blue channels. So I separate the red channel and then flatten the red and the blue to separate the green channel, and then flatten the red and the green to separate the blue channel. And of course, I recorded myself doing that in an action and also edited layer masks. And if you turn off the original image and the luminosity layer, you can view the color composition adjustments, or turn off the color channels and view the tonal composition adjustments, all of which supports profoundly impressive visualization and pictorial literacy. There you go. That's how we go about creating our profound, proportional colorizing action that we still to this day like to call Lobster, in memory of Ian Lobb, the great teacher and artist that he was, and in memory of that quarter of a century that we shared together. I was worried it was going to be a bit of a roller coaster ride. Hopefully I got to answer those questions, and fingers crossed, to the level of satisfaction that it's more helpful than not. And as always, thank you for the company. An absolute delight to catch up as we do each week here. Looking forward to the next encounter. Don't be strangers. See you soon. Take care. Cheers.